Let us evaluate the double integral of e to the power minus x square as x changes from y by 2 to 1 and then y changes from 0 to 2. You see that if we want to do it directly, that is we have to integrate e to the power minus x square dx, but we do not know any closed form for e to the power minus x square. If we want to integrate it, e to the power minus x square, simply we don't know how to do it. So what we do is we go for change in order of integration. So what we will do is we will try to do integration with respect to y first and then integration with respect to x first. Luckily we are able to do it. Let's do it. Now x equal to y by 2, that's a straight line passing through origin 0, 0 and 1, 2. Once again, x equal to y by 2, that's a straight line passing through origin and the point 1, 2. Then x equal to 1, that's a straight line parallel to y-axis and passing through 1, 0. As we said, we want to evaluate the integral from x equal to y by 2 to x equal to 1. That is, x is changing from y by 2, x equal to y by 2 to x equal to 1. Let's say the reason. X is changing from x equal to y by 2 to x equal to 1. X is changing from x equal to y by 2 to 1. So this is the exact reason over which we want to evaluate the given integral. Can we do it differently? Can we draw vertical strip rather than horizontal strip? Can we draw vertical arrow rather than horizontal arrow? So let us draw the region once again. Okay, now we draw vertical arrow rather than horizontal arrow. We draw vertical arrow rather than horizontal. Will we be getting same region of integration? Of course, yes. So in this case, we will be changing y from y equal to 0 to y equal to, say, x equal to y by 2. That means y equal to 2x. So y will change from y equal to 0 to y equal to 2x, and then x will change from x equal to 0 to x equal to 2. Sorry, x will change from x equal to 0 to x equal to 1. Let's do it. Let's write the given integral once again. So we are changing y from y equal to 0 to y equal to 2x, and then x from x equal to 0 to x equal to 1. We are changing x from x equal to 0 to x equal to 1. Are we changing the region of integration? No. Are we changing the function? No. So the answer should be same. What is the function? The function is e to the power minus x square dx. Once again, we are not changing the function e to the power minus x square, and we are not changing the region of integration, so the answer should be same. However, during this process of changing order of integration, we got a much simpler integral that we can integrate it, e to the power minus x square, that is independent of y, so we can just regard it as a constant while integrating with respect to y. An integral of 1 dy is simply equal to y. We need to change y from y equal to 0 to y equal to 2x. At last, we need to integrate from x equal to 0 to x equal to 1. Now once again, for the time being, when we are doing with respect to y, we regard e to the power x square to be a constant. When we write y equal to 2x, we get 2x. When we write y equal to 0, we simply get 0. So we are evaluating the inner integral. Now it's time to evaluate the outer integral. See that x is changing from 0 to 1. Next, now it's a simpler integral. We simply let x square equal to t. Then as x changes from 0 to 1, t also changes from 0 to 1. And then e to the power minus t. And then if we differentiate both sides, we get 2x equal to dt. 2x dx equal to dt. Okay, so we simply write dt, and integral of e to the power minus t is e to the power minus t by minus 1. We just need to write the upper and lower limit. E to the power minus 1 minus e to the power 0, that is 1, by minus 1, that is equal to 1 minus 1 by e. And we are done.